Today we're going to review how from a system that we have generated the bond graph and we generated the block diagram, how do we actually transfer that to Simulink? So what you have on the screen here is the example, the physical system, and the bond graph model that we have built from it. We follow these steps as you have seen outlined on the right hand side of your screen. It says to recognize what elements you have. 2, we use a one junction for each distinct velocity, including in this case the velocity of the wall. So that's this one, and then there's the other one for the mass. Then we attach the elements that experience those velocities, this one, which is this force, the inertia element, which is this mass, and then we have a source of flow in here for the wall, which is our reference with velocity equals to 0. The reference makes it easier to build this bond graph. Of course, we can simplify it later, but it's not a hugely necessary step. And here we have using a zero junction to represent the velocity differences. Obviously, there's a difference between the velocity of the wall and the velocity of the mass. So these two elements see the difference between those two. So the way we express that is we say this minus this is x1 dot minus the velocity of the wall, and this is what these two elements see, and therefore we have this. So what we have done in the previous lecture is to generate a model using the CAMG software of the same thing we have on the screen on the left hand side. Now we have it into the CAMG software in here. And then from here, we went ahead and produced the block diagram of this using this bond graph model. So this morning, what I want to do is I want to start with this block diagram that we built in the previous video. And using this block diagram, I want to transfer it to Simulink. Okay? What I suggest when you're going to draw a block diagram that you already have on paper, that you're going to transfer it to Simulink, is that you open a window in Simulink to work, and then on that window, you put the elements that you're going to need. Don't do anything about the connections or anything, but just put the elements that you're going to need. In this case, before we get started on doing that, you see, you need a couple of sources, which I think for the purposes of this example, we are going to consider them constants. So that you have one in here, and of course this is 0 on this other side. And on this one over here, you see on this element, this I element in here, obviously we're going to need an integrator and some gain and some summation points over here like this, and here another integrator and another gain and a gain over here. So it's actually pretty simple. What we need to do is to build it in such a way that it will resemble this as much as possible, but it could be that not necessarily would be exactly, okay? So it might have, the lines may not look exactly the same, but the connections will. The connections have to be the same. Okay, so we go ahead and do it in Simulink, and let's see if we can have this as a window in here that we can actually refer to. Perhaps I'll do it a little smaller here. So, and then you can see I have already opened my Simulink menu and also define a new workspace in here for this. See where it says commonly blocks. You have a menu of these commonly blocks that you're gonna use, and like I said, we're gonna need the several of this. How many gains do we need? 1, 2, 3, at least 3 of this. If we need some more, you can always do copy and paste. I'm just gonna put in here. We are going to need a couple of these integrators. And the summation points, we need about 3 of these. Yeah, and then what else do we need? We need the constants. We know at least of 2 of those. Okay. Let's see. Well, if we need to, we come back. What's the most important thing is that we have these 2 windows that we have in here. You can start basically anywhere, but I think it's a good idea to start just in a similar way of what you have in there. So we could go and put and say, okay, this is my this. You see the constant over here. Let's keep that one over there. And you have an integrator and some constant at the top. There is a summation point someplace in here. Then there is a summation point someplace down here. And then there is another summation point that we need. So we'll bring another one over here so that, let's see, someplace here. We can accommodate we can move things around. No? This one is on here. We have a integrator down here. This, and also we have it some integrator. We need to flip it, but we need another one of these. Let's see. We need this one down here. Yeah, right here. Okay. Let's get a little bit more to the nitty-gritty of this thing. See that we're doing the top right here. So what I would do is, see this one, I could just put it like this at the same level, and you have the summation point here has two connections. One is minus, the other plus. So I double click on this and I put the signs the way I need them on the, so you have the output of this is connected over here, see? And the input is coming from this source here, from this one. But you see this, if you do a control I, it flips. And then you connect this one to this. Yeah, see, this integrator up here is connected to the other one that is like 1 over L. If you double clicking here, we can put it exactly as we mean it in here, 1 over L, like this. And then you say, okay, see, there it is. Okay, so so far we have done this. You see this one, to be able to do this, we need another connection that we don't actually have right now. Actually, we think we do. Let me see. This one is, this 2 is also a minus and a plus. So this would be minus, and then a plus. And now we have what we need. See, we need for this one right here. So the minus sign is coming from the source of flow in here, which is this one right here, the minus sign. Yeah. Remember, the source of flow is just producing this signal for the flow in here. So we don't need to have a two-way street for the sources. It's just one way. But the output of this, see, I think did I make a mistake? Yes, I did, because that connection is not for this. It's for the one on the bottom. It's for this one. Yeah, right there. So that we have done this. You see, from this other one, from the output of this, comes the other one into here. And that we need to do from here. See, you need this connected to that. How come it went around that? Well, okay. Simulink tries not to cross lines. For now, let's obey the way it is and leave it alone. And then the output of this is going to go on the input of this gain over here, like this. Yeah, this thing is gonna go there. That makes this, and then we have on this side over here we have, what do we have, a minus or a plus here? I didn't write it down, but I think it's both of them are plus, I believe. Yeah. So you have the the output of this game from the bottom, this one, needs to go in here. Okay. And this, it looks like, needs to be inverted a little bit. Okay. Um, the integrator is first and the other one is like this. So both of these need to be inverted. See, Control I, and this Control I inverts both of this to make this up. So then you have so this one goes here. This, of course, goes in here. This is like 1 over C. Yeah, very good. And the output of the gain down here is the other input here. And this connects to, you see how this connects to the one that goes from the source. So where is that? Yeah, right here. So this goes right here like this. The computer, it does red when the connection is not quite right. Hmm. I'm having problems with that. So whenever you approach a connection, it changes. The cross changes. Yeah. I'm having this needs to connect here. Unless I need to make it big, because it's obviously not connected. Well, let's leave that for a moment, and this, because okay, this one in here, see how it goes. We need to connect this to this. Maybe after I have done that, would it help me connect this in here? I don't know why it wouldn't do the connection there, but that's where it needs to be. So now this, you see it's got a common point to this. Perhaps we can move it down a little bit, and you'll see that this is, see, this one connected just fine. So we got this, we got this. Okay, so the bottom one is perfectly well. Let me see how we're doing with the one at the top in here. This one, you know where this thing goes, and is to the other end here. That's why. So this thing connects here. That's what this is, see? This connection between this and this is not necessary because this is a source of flow, see? But this one is to here. We have the integrator there, and from here, and on the other hand, this one connects to the source of effort, but not the flow. But the output of this connects to this over here. I think we got it. I believe the question that comes up is how come this one doesn't have two and this one doesn't have two? This I'm gonna call it SE in here for the source of effort in here, but this other one is a source of flow with velocity equals to 0. And this is the block diagram of this. See if you can put it side by side in there, perhaps. It's a good idea to see it like that, maybe a bit like this. So I grant you that the Simulink comes just a tiny bit different than the actual one, but what is important is the connections that we have, and what we are saying here is that in this case we have two sources of different kinds. The source of effort on the right hand side produces just that, an effort variable. The source on the left, the source of flow, in this case the velocity 0, this one produces just the flow. And in here I think it's a good idea to complete here this is our element in here. There we go. And this way we have completed translating my block diagram that I produced from the bond graph model into Simulink. And from here we could do a simulation and pick up any values, perhaps any outputs that we want. Like for example, if you want the what signal can we output in here? Let's say the velocity of the mass. Where would the velocity of the mass be? The velocity of the mass here we have is for variable this signal, this F2, this is the one that we would take a scope like this, for example. I would say let's put the scope into the into what we need, into my, and my output would be this one, this variable like this. There you go. So if you, by default, this is interesting. Simulink initializes to 1 every single variable, but we would need to give some values to really make any meaningful run at this. But on the other hand, you can by the values that the Simulink has put out. And then, of course, in here, it complained because I didn't, I have all these values, L and R and C, and to be able to do the simulation, we need to define those numbers. But we could if you want to see it, but we're not really doing something really significant in here. Sorry, this is the correction. It's not L, but it's M. The mass is what we have in here. Okay, so we could, if we initialize that, we could obtain some result in here. Of course, to be able to do that, you should do it at the MATLAB prompt. Yeah, we need to do it at the MATLAB prompt. And then once you initialize that right here, just for the sake of example, we'll say R is equal to 2. Let's put M equals to 3. And C would be, C is this, 0.05. Let's see how we do with those numbers. We go back to the Simulink 1, and then we'll, right here. This is, let's see how we did with initialization. Which other variable? The sources, the two of them. We didn't do anything. So let's go over here. This value is E. Let's go equal to 10. And of course, this SF was 0. Yeah, there we go. Let's try again. And now obviously it did a run, see, very nicely. Okay, so this proves that our block diagram it's okay. Just like we would have done it from the equations, but in fact this represents the equations as we would see in another lecture.